Hello, pre-calculus students. In this lesson, we're going to learn what's called the law of sines. Now, in theory, if I stick to what I've always done, I've already given you a handout in which you would derive the law of sines. It's kind of a hand walking you through the process. And from that handout, you would see that the sine of angle A divided by the length of A is equal to the sine of B divided by the length of B is equal to the sine of C divided by the length of C. In other words, if you have two angles, or I'm sorry, let me rephrase that. If anytime you have an angle and the side opposite, doesn't matter which angle and which side, as long as you have an angle and a side opposite, you have the sine ratio for that triangle. So if you know side A, or I'm sorry, angle A and side A, and you know angle B, you can calculate side B. And then if you know A and B, add them and subtract from 180, you get side angle C, and then you could get side C. You can solve the triangle. So here's a checkpoint problem from page 403 of our current textbook. Let's cover up most of this so it's not so intimidating. And what is in black is what is given. I have side or angle A, angle B, side A. So I do have an angle in the side opposite. So I can go sine of 30 degrees divided by 32 is equal to the sine of 45 degrees divided by little b. Notice when we label the triangle, the big letters are the angles, the sides opposite them, the lowercase letters are the sides. So I can solve this equation here for b. First I took the reciprocal of both sides and multiplied both sides by this denominator, and I get little b is approximately 45.3 units. So now I have this angle, this side, this angle, this side. I have these two angles, so I can automatically get angle C is 105 degrees. Now all I need to get is side little c. Well, the 30 degrees and the 32 degrees were exact values. This 45.3 is a decimal approximation. So I didn't use the 45 degrees and the 45.3 over here because I don't want to put an approximation into my formula because then I'm introducing more error. So I stuck with the exact values I know. I know 30 degrees. I know 32 exactly. I know 105 exactly. So then I just solve for side C, where I get the 61.8 units. So now this triangle is completely solved. Now you say, if you have angle, side, angle, in no case here do I have an angle in the side opposite, except that if I have two angles, I know the third angle. Now I have an angle in the side opposite, I can solve the triangle. So angle, side, angle works great. What doesn't work great is if you have side, angle, side, because there's no way to get either of these other angles or this side using the law of sines, because we don't have the sine ratio for that triangle. In our next lesson, we're going to learn the law of cosines that will allow us to deal with side, angle, side. Now, there is a situation, and that's when you have angle, side, side. And I refer to it kind of humorously as a pain in the angle, side, side, because there are two possible answers. So let's say that I'm given this angle A, this side B, and this angle A over here. I'm sorry, side A over here. There are three possible situations here. One, side A is too short. It won't even touch this side down here, in which case there's no solution. How long does that have to be? Well, we drop a perpendicular from this point down to this line, and we'll call that H. And you can see pretty quickly that B times the sine of A, you could solve little b times the sine of A would give us this. So if little a is shorter than this perpendicular distance, which is the shortest possible distance, there's no solution. If A is exactly equal to H, there's only one solution, and that's the right triangle. Now, if A is between H and B, and I don't want you to write this down and memorize this or look at your notes, I want you to understand this. If A is between H and B, there are two solutions. And that is because it's longer than this minimum, which means it could come out here, or if you swung it like this, it could touch over here. So your angle B could be this acute angle, or it could be this obtuse angle. And then if A is greater than or equal to B, well, there's no way it could touch out here if it's greater than or equal to this. So the only thing it could do would be to come out here, and there would be only one solution. So whenever you have angle side side, my recommendation to you is always assume there are two solutions and try to find them both. And if there's only one solution or no solutions, things will turn out yucky, like you'll get a sine of an angle greater than 1, and you know that can't happen. Now, this angle side side, that's called the ambiguous case of the law of sines, because there could be two solutions, but really, you could have 0 solutions, 1 solution, or 2 solutions. There are 3 different situations there. But I'm not sure it should be called ambiguous case, unless ambiguous means we don't know for sure. Usually you think of 2. So again, I always assume there are 2 solutions when you're using the law of sines to find an angle. Now, if you're using the law of sines to find a side, no problem. But if you're using the law of sines to find an angle, there are 2 possibilities. For instance, let's say you come up with sine of angle B equals 0.6. Well, there's a first quadrant angle, that acute angle, where sine is 0.6, and there's a second quadrant angle, an obtuse angle, where sine is also equal to 0.6. I say try them both. And you might be thinking, what do you mean by that? Well, let's do a sample. So here we have triangle ABC. We're given that angle A is 58 degrees, side B is 5, side C is 4.5. Let's find angle B. We have the ratio. So the sine of angle A divided by side A is equal to the sine of angle B divided by side B. Solve for the sine of B. And now we know that there are 2 angles, a first quadrant angle and a second quadrant angle, that will give us this sine. We take the arc sine of this and we get a first quadrant angle. How do we get that second quadrant angle? Reference angles. What second quadrant angle has a reference angle of 70.4 degrees? Well, it would be 180 minus 70.4, which is 109.6 degrees. So I say we're using the law of sines to find an angle here. I say we assume both of these are true and see if we can get 2 triangles out of it. So here's what we were given. Angle A is 58, side A is 58 degrees. Side A is 4.5, side B is 5. And we got angle B is 70.4 degrees down here. So now we know if this is 58 and this is 70.4, side C is, or angle C is, well, I need to really get this straight, don't I? Angle C is 51.6 degrees. That's an exact value, isn't it? No, it's not. It's approximation because this was an approximation. All right, so we have 51.6 degrees. Since this was an approximation and this is approximation, but we do know the 58 degrees exactly and the 4.5 exactly. So let's use this ratio. Now it equals sine 51.6 degrees over over side C, and side C is 4.16. So everything looks good here. All of our angles add up to 180 degrees. The biggest angle has the longest side opposite. This is a legitimate answer, but it's not the only answer. Because over here we had angle A was 58, side A was 4.5, side B is 5. And we solved for angle B was a possibility of 109.6 degrees. Well, you add this and subtract from 180, and you get C is 12.4 degrees. And then sine of 58 degrees over 4.5 is sine 12.4 over side C. Solve for C and you get 1.14. So in this case, we do have two solutions for that triangle. It could be this acute triangle or it could be this obtuse triangle. Now here's a case where there's only one solution. You'll notice that if we drop that perpendicular down here, it would be less than 5 because 5 would be the hypotenuse. And this side is 20 units long. There's no way it could it could swing over here and touch anything along this line segment. So we know there's only one solution. But since we're using the law of sines to find angle B, let's assume two solutions and see what happens. So sine of 58 degrees divided by 20 is equal to the sine of B divided by 5. The sine of B gives us this value, take the arc sine, 12.2 degrees. Now, there is a second quadrant angle if this could flip over here and give us an acute angle. We know it can't, but let's just see what happens. That second quadrant angle B would be 180 degrees minus 12.2, which would be 167.8 degrees. Well, if B is 167.8 degrees and A is 58 degrees, you're already over 180 degrees. So this triangle isn't going to work. Only this triangle is going to work. Now you go on and solve for angle C and side C. So remember, angle side angle we like. Side angle side, we have to use the law of cosines, which we haven't learned yet. Angle side side, where you're trying to find a second angle, is a pain in the angle side side because you have to assume two solutions. All right, finding the area of a triangle using the law of sines. Well, the area, and I don't know why we use K for area, but we do, is 1/2 base times height. Well, the base is C, and the height, H, is B times the sine of A. Take the sine of A, you get H over B, solve for H, and you get B sine A. So area is 1/2 BC sine A. So you can see side angle side, we can find the area. We can't find these other angles or the other sides, but we can find the area. And of course, if you switch all the lettering around, You'll notice that if it's BC, if you know sides B and C, you need angle A. If you know sides A and C, you need angle B. If you know sides A and B, you need angle C. So those are the formulas for finding the area. Now remember, if you're using the law of sines to find an angle, assume two solutions. So sine of 38 degrees divided by 10 is equal to the sine of B divided by 12. Solve for the sine of B, you get this value. And there are two angles that have this sign. You take the arc sine of this, which gets you into the first quadrant. Remember our principal values, get you into the first quadrant. And then if there's a first quadrant angle that has this sign, the second quadrant angle must have the same reference angle. So it would be 180 minus this. And what that looks like on a circle is if this is this, if these are, you remember your y coordinate on a unit circle is your sine. If this is 0.739, well, this angle, if this is angle B from our last slide, it has a cosine as the x coordinate and the sine of 0.739 is the y coordinate. You'll notice that 180 minus B, because B is the reference angle here, gives us this obtuse angle, but it has the same sign. So if we go back and solve that triangle, we were given 38 degrees and we were given sides A and B of 10 and 12. So angle B could be either this or this. Well, if angle B is this, angle C is this. If angle B is this, angle C is this. And then based on these, what is side C? You should work that out now. So what we've done here is we've learned what's called the law of sines. You must have an angle and the side opposite that angle in order to establish the sine ratio for that triangle. There's also a law of cosines, which we'll use if we have side angle side, where you don't have an angle and the side opposite. But that's our next lesson. We're going to have enough fun with this lesson, so have a great day.